Wait, hold on. Okay. Go for it.
Good afternoon. My name is Julie Duncan, and I am the superintendent of Tri-Valley ROP, and I am so pleased to be the moderator today for Tri-Valley's Manufacturing Day, Advanced Manufacturing and COVID-19 Recovery and Workforce Development. I am so pleased to be asked to be the moderator. I have been working with Manufacturing Day for the past 7 years with the cities of Dublin, Livermore, and Pleasanton, as well as the 3 school districts they represent and Las Positas College. I'll be your moderator. As I said, I'm working with Lisa Adamos from the Economic Development Manager of the City of Pleasanton, and Rhonda Franklin from the Management Analyst from the City of Dublin, and of course, Teresa de la Vega, Management Analyst for the City of Livermore. You know, during the pandemic, we've continued educating our students about advanced manufacturing here in Tri-Valley through virtual tours and online workshops. We used to go out to your businesses. We used to go out to the manufacturing world and try to expose students to demystify it. You know, manufacturing sounds like a really big word. There's a lot of connotations that people think of when they think of manufacturing, depending on the decade they were born in. And I think people don't really realize what's in their back door. And so Manufacturing Day really became the window, the opening of the eyes to not only your community, but also to the students of the opportunities right here in their hometowns where innovation is just thriving. And we're so excited to be part of the Bay Area Urban Manufacturing Initiative today. And I am also very pleased that we have 3 companies representing each of the cities that I mentioned, talking a little bit about what their company does. And, you know, we'll also be getting to ask during our Q&A piece, what is it that students need to be, you know, really looking for in careers? What do teachers need to be teaching? What are the skills? And we all know the soft skills, but what are those technical skills? What are the thought processes that you really want students to be thinking of, both in our district as well as at the college level? And then for those employees who are maybe looking for a change, you know, what are these companies looking for? I want to obviously acknowledge, I know there's a lot of elected officials on this call, and I want to thank them for being here today. Our business community leaders that have joined us via the webinar. And again, this will be recorded, which we're excited about, to be able to give this to our teachers and also to be able to put it on our city websites for people to view, because I know during this time we're also very busy. So without further ado, I want to talk a little bit about how the day will run. We have 3 speakers, and our first speaker will do Q&A right after Chris, and then he needs to leave a little bit around 2 o'clock. So our next 2 speakers, we'll just have them go back to back, and we'll have the Q&A after. You can put your questions in the chat box, and Rhonda will be looking at those, and we'll be asking those questions after the speakers have finished. So we just ask for you to be patient, and we'll make sure we'll get to your questions. We're going to learn a little bit more about the L&L's Advanced Manufacturing Laboratory from its division leader, Chris Spadaccini, and interview Kingston Laboratories President and CEO, Raj Kaul, and Omron Robotics and Safety Technologies, Inc. Director of Manufacturing, Venkat Rajagopalan. To learn about their businesses and how their companies have adapted during the pandemic, including the types of training and experience required to work in their industries. And we encourage you to, you know, ask, you know, how can you help in your community? How can you get the word out? And we'll try to get those questions answered as soon as we can. So let's get started. Our first speaker is Chris Spadaccini. As I said, he's the division leader at Lawrence Livermore National Laboratory in the Materials Engineering Division. Chris has been working in advanced additive manufacturing process for over 13 years and has over 65 peer-reviewed journal publications, 4 book chapters, and more than 40 patents awarded. He's currently an adjunct faculty member at the University of California, Davis, go Ags, it's my sister school, and the Chemical Engineering Department, and has been a lecturer in the Chemical Materials and Biochemical Engineering Department in San Jose State University. And I know he works a lot with the Education Department at LL&L with Joanna Obala, and has been great working with our students. So Chris, I'm excited to hear from you.
Great, thank you for having me. I was going to start off with a video about the Advanced Manufacturing Laboratory. So I'm going to cue that up right now. Hopefully you can see it okay. And let me make sure I share the sound. All right.
Hello and welcome to the Advanced Manufacturing Laboratory at Lawrence Livermore National Lab. We're here in the open campus of Lawrence Livermore National Lab, and this is a new facility, about 14,000 square feet, primarily laboratory space.
We are an advanced manufacturing facility, and so we do all things advanced manufacturing. So we do a lot of 3D printing. We do with both commercial systems as well as systems that we've built on site. We do a lot of work with a lot of different materials. We work with metals, we work with polymers, we work with biomaterials as well to try and create new and fun, happy devices. That's our key here, fun, happy devices. So a lot of this area of the lab right here is dedicated to our metrology equipment. So we have rheometers, we have spectrometers, we have SEMs, we have high-powered microscopes. This is mainly so that we can characterize all of the parts and the materials that we make to make sure that they have the right properties, the right mechanical properties, the right, that the parts end up looking correct. As we move further down here, we get into kind of, the guts of our advanced manufacturing lab. So I would say in this area, we do maybe, I would say, 3 kinds of manufacturing processes. So we do, one is a capsule-based manufacturing process. So this is where we make small capsules. So these are, one of the primary uses for these is we actually do CO2 capture. So these will absorb CO2 and we can take it out of the atmosphere.
Here in this laboratory, we're working on advanced research and development in the areas of advanced materials and manufacturing. We have projects ranging from metal additive manufacturing all the way to carbon capture for environmental projects. We work with industry partners that can be large multinational corporations such as GE, all the way to local startup companies here in the Bay Area. We spend a lot of time developing new materials for these processes. We want, them to have certain properties. Oh, they need to have this, mechanical strength, or they need to be magnetic. In some cases, we also do bio as well. So they need to have some biological molecules in the structures that we're working with. So we built these systems, and there are several of them at this point to kind of build up that setup. As we come further down here, this is our Aerotech machine. They're one of our prime collaborators here in this facility. And we're trying to advance manufacturing. So maybe not, this one is not, oh, let's develop a new printing method. But let's do a way to make advanced manufacturing smarter. So essentially we're building a system that's automatically gonna monitor the part as it's printing and when it's done, and it's gonna scan that and say, does this look like the part I wanted to create? And if it doesn't, it's gonna go back, make the changes in the code to say, okay, no, it needs to look like this. And then it's going to print that, and then it's going to come back, scan that, and do this automatically. And so with this one, we've actually incorporated a robot arm that's actually going to be key to moving the parts from point A to point B, and developing, and again, making advanced manufacturing smarter. On this side is our volumetric additive manufacturing system, otherwise known as computed axial lithography. This one is this one's a really different system for doing 3D printing. Traditional methods use layer by layer approaches. They print a layer, then they print another layer on top, and they print another layer on top. This system actually builds the entire thing at the same time. So it's not a layer by layer approach. It uses some high-powered math to generate that, and essentially you have a vial of your material, and you project light all around it, and as the material cures, you get your whole part built at one time. So with that, I want to thank you for watching this video, and I'm looking forward to one day hosting you here at the AML. Thank you.
Okay, so with that little bit of introduction and video, I'd like to tell you a little bit more about that laboratory and some of the other things we're doing at Lawrence Livermore in advanced manufacturing. So with that, I'll once again share my screen. And tell you a little bit about some of the other activities and some of the highlights of what we're doing in the Advanced Manufacturing Lab. I just like to preface a lot of what I say that you need to think of advanced manufacturing, in my opinion, as an ecosystem. That's how we at the laboratory think about it. It's not just a machine that builds a part. It's really all of these things you see on the screen right now. If you have a new advanced manufacturing process with enhanced and improved capabilities, where you can make new kinds of geometries or use new materials, you really need to be redesigning your components, in our opinion. So we have an entire aspect of what we do, which involves new computational design methods, essentially using the computer to do the design for you and kind of taking the human out of that loop. It can come up with much more non-intuitive yet high performance designs, such as the highly complex bridge structure you see on the left. That also couples to materials. The materials that go into these processes, whether it's an additive process or otherwise, are absolutely critical. They must be high quality and you must understand them. Then third is the process itself that makes the part. That process could be a commercially available tool, or it could be something at the laboratory that we've developed ourselves, often in partnership with industry or academia for ultimate commercialization. And I'll show you an example of that in a moment. And finally, for the laboratory, of course, many of you may know, we do have a national security focus. Qualification and certification are really paramount. And I'm betting my industry friends here on the call will tell you something similar. In order to actually use these new processes and new materials and structures, we have to, quote, qualify with a very high degree of confidence that they're going to work in their intended field of use. So what does that really mean? Think of, say, the Federal Aviation Administration. If you're going to create a new turbine blade for a jet engine, you can't just put it in an engine and fly people. You have to go through a very rigorous and long process of testing and evaluation to really understand that it's going to work. And we do that through simulation, through in situ diagnostics, which you heard about a little bit in the video, basically measuring the part as we build it. Also, a series of experiments and tests that may be destructive. We may cut the part open and look at it. All these sorts of things have to be done in order to really understand how these things are going to perform and to have the confidence that they're going to work in their intended use case. So I want to highlight one example of a new process that we've invented and now we're working on. We invented it with Cal Berkeley. You heard about it in the video, called volumetric additive manufacturing, or computed axial lithography. Essentially, this is like inverse CT scans, and I think it's quite remarkable. If you take a 3D CAD model like you see in this animation, and you use the same mathematics you use for a CT scan, but in reverse, you can create something that looks like an X-ray image in the computer at different angles. You can then project that as a sequence in time from a projector and focus that into a rotating vial of liquid. That liquid is what we call a photosensitive resin. Wherever it gets hit by light, if you dose it properly, it will solidify. So by doing this in this, quote, tomographic way, we eliminate layers and points and create the part all at once as a volume. So quite a remarkable and very new process. And that was an animation. So of course, in an animation, it always works, right? But does it actually work in real life? So here's a video sped up. That's time in seconds on the upper left. You see a light shining into a vial, and our friend, the thinker statue, it's only about 1 centimeter high in this case, but this is just an experiment, forms in about 50 seconds and just a few revolutions of the vial. So this is just one example of some really remarkable new work that we're doing at the AML. And we do have industry partners. A couple of different startup companies have been working with us to improve the materials for this and to see if we can commercialize it in the AML. So it's very exciting work. And again, just an example of early stage research being transitioned with partners in the Advanced Manufacturing Lab. So the Advanced Manufacturing Lab, if you're not familiar with what was said in the video, is part of what we call now the Livermore Valley Open Campus. You see it pointed out there on the lower left. This is on the west side of the laboratory's perimeter. If you're familiar with the laboratory, excuse me, east side of the laboratory's perimeter. We've actually moved our security fence because, again, we are a national security lab, such that you do not have to go through our main security perimeter to get to this laboratory. And in fact, we're intending and working on building out a whole campus there for academic and industry partnership. I won't go into too many of the details of that, but suffice it to say, the point is to better interact with the external community, leverage what we can learn from them, while simultaneously spinning out what we have learned in our own programs. So this is a picture of that building that you saw in the video. And again, the business model here is partnership. So we really want to work with companies. It's not a user facility. So you don't just pay money and sort of come to the facility. The idea is we form joint projects that could be funded by an external organization, could be funded by the corporate partner, or perhaps we both have just such similar goals that we're already funding our own folks to do the work. We're just better off doing it together. But the idea is that we derive benefit from the partnership that we can use in our internal programs while simultaneously providing value to our corporate partner. And this building was fully commissioned about 2 years ago, maybe 6 or 8 months before COVID. We were starting to populate it with equipment and projects. And even during COVID, we were still able to keep doing some work. And the building's now quite full with many partnerships. You see some logos at the bottom of the screen, again, ranging from multinationals all the way to startups in a variety of different areas, such as manufacturing processes, new materials, computation combined with manufacturing, additive and otherwise. So just to give you an idea of the kind of folks that we work with in this facility. So with that, I know we're a little short on time. We had the video to explain sort of some of the things going on inside. I'll stop sharing my screen and just say that it's been a pleasure to be here. And I'm really happy to have been able to spend a few minutes with you showing you the AML and some of the work we're doing. And I'd be really happy to take a few questions with whatever remaining minutes that I have.
Thank you, Chris. It was so great to see that laboratory. I've seen a couple different videos on it, working with Joanna Obala, and to be able to see that the different businesses that spin in, spin out, and collaboration is great to see between the businesses as well as education. So I thank you for that. I don't know, Rhonda, is there any questions in the chat?
There are no questions in the chat at this time, but please, if anyone has any questions, please feel free to enter them into the chat.
Okay, well, I know I have one for Chris. What have been the most effective ways to adapt and or to respond during COVID-19 with this lab protocols?
So it was a challenge at first, frankly, because this is very hands-on activity. Obviously, you can only do so much from home. So we set up a series of safety protocols, and looked at population density working in the laboratory, but ultimately we were able to do it, I think, and be quite effective. We did also do quite a bit of work from home when we could, whether that was simulation, or in some cases, some of our experimental setups and some of our manufacturing tools could be run remotely. Which is we were sort of forced to that, which is actually kind of interesting because you'd actually like to go in that direction anyway. So it allowed us to test out some of those concepts and perhaps actually acquire data or run, say, a robot arm from a remote location. So in that sense, it was actually quite interesting. But I think we were fairly successful in getting up and running again in a month or two after COVID first hit, and really making some good progress. I'd also like to mention that we did some work in the advanced manufacturing lab that was very specific to COVID. The Department of Energy, national labs banded together and worked on multiple different projects together. We in the advanced manufacturing lab worked on 3D printed nasal swabs for testing of COVID-19. We printed some of those and we established some test protocols for looking at their mechanical behaviors as well as their ability to absorb samples from a human, and provided that to the greater community, the medical community nationwide. So we actually used the facility to respond directly to the COVID-19 pandemic.
And Chris, how do people go about, if I'm a business and I'm interested in partnering, how do I even do that with the lab?
Yeah, great question. Early on, we had an industry day to sort of open the doors and look for these partnerships. At this point, you could directly contact me. I can provide contact information after the meeting. Or we also have a website where you can go in and you can send us a message that says, hey, I'm working in this field. I'd like to talk to someone about it. Is there a potential partnership project here? So that's kind of how we do it now. So multiple ways to contact us. But again, we're looking for a joint project as opposed to, say, a partner coming in and just using the facility. But we're very happy to entertain possible new partnerships. We do have more space in the facility, and we can reconfigure the facility for additional work. So we're very excited to talk to folks about potential joint R&D efforts.
All right. Well, I know the audience out there, we've got people maybe looking for a new career, or we have teachers watching they're working with our students in the STEM pathways. What types of training or skills or experience is really required to even start in this industry? What would be your advice?
So speaking a little more from the R&D side, I would say that a solid foundation, technical foundation is key in some type of engineering or science field. And I always say that because it is a technical field. So really having those underlying skills is important. It's not quite as important, in my opinion, to overly specialize. Having good fundamentals is key. But I'd also say, and I think you mentioned in the introduction, soft skills, that communication skills are really critical. So it's not just about being a good engineer or a good scientist and contributing technically, but being able to communicate what you've done, being able to communicate new ideas to stakeholders at the right level is really critical to your success in your career, but it's critical to advancing the field as well. If people don't understand what you've done or what you want to do, you're probably not going to get to do it.
Great. That's great advice. Does anyone else have a question from our panel for Chris? Rhonda, I didn't know if there's anything else that came across during this time at all.
No, still no questions in the chat.
All right. Well, Chris, thank you so much for coming and taking part of your day to let the community of Dublin, Livermore, and Pleasanton really get to understand a little bit more about the laboratory. I am excited that the fence moved. I didn't really realize all of that. So for someone who's gone to taking kids for many field trips, I appreciate that there's more access to the lab. That's great news. So thank you.
Great. Yeah, we're trying to build that out even more. So we're very excited about it.
Perfect. Thank you, Chris.
Thank you all.
Have a good day. All right. Well, on to our next presenter. Before we begin, I want to just reiterate again, we're going to do Q&A after our next two presentations. And I said I was from Tri-Valley ROP. I neglected to say what that was for those of you on the call that don't know what Tri-Valley ROP is. It stands for Regional Occupational Program. We work with all 3 school districts, and some people remember it as, oh, it was SHOP. Well, we're a lot more than SHOP. We prepare students to be college and career ready. And so our classes, we have STEM classes, Project Lead the Way. Many of you are involved in those classes. We have automotive in Livermore. We have actually advanced manufacturing engineering at Dublin High School. Our students travel, our juniors and seniors travel between the high school campuses because we can leverage our resources, our dollars, and our facilities. It's very expensive to have career tech ed classes. We have medical occupations and we have nursing, we have animation and motion graphics. Those types of classes cost a lot of money. And we don't always get, a big group of kids to sign up for a particular class. But if we can leverage the businesses, because I know someone like Chris in the lab, they like to see us partnering and working together. It's hard to give money just to one school or a resource to one school. They want to see us working together and using those dollars wisely. So that's a little bit about Tri-Valley ROP, and I'm very proud to work with all these partners that are on the call today. So with that, our next presentation is Kensington Laboratories. Raj Kaul is the president and CEO. He's been there for the last 16 years, and he has 35 years of experience in robotics and semiconductor capital equipment and engineering. He's an undergraduate degree in mechanical engineering and a master's degree in technology management. So you don't really know much about STEM, I take it, Raj. I'll go ahead and welcome. Thank you for being here today.
Thank you, Julie. I am going to start with a presentation. If I Thank you, Julie, again. So we're Kensington Laboratories. We're located in Dublin, California. We are in semiconductor automation equipment business. And what does that mean? My computer is a little slow. Need better automation. Can you see my screen?
Yes, we can see it.
So what does semiconductor automation mean? As we all know, semiconductor or computer chips are everywhere. We know Apple sells about 500,000 iPhones a month, and each phone, well, that means 350 phones every minute. And then each phone has about 500 computer chips. And if you multiply that, that's about 175,000 chips every minute that just Apple alone uses. We know an average car nowadays has anywhere from 500 to 1,500 semiconductor chips. So the demand for semiconductor chips keeps increasing, and it's not possible to make all these semiconductor devices by hand. So there's a lot of automation required. A typical semiconductor fab looks like this, or factory. They're known as fabs. So Intel has few fabs. I know Intel many years ago had one small fab in Livermore. I think since then it has been shut down, and they have moved the fab. They have consolidated their operations in Albuquerque, New Mexico, and Arizona, and also some in Portland, besides other fabs around the world. So a fab where these computer chips are made looks something like this. There are many sections within the fab. It's a big, massive factory. And then inside the factory, there's a picture on the left where it's a silicon disk or silicon wafer. And these squares that you see are each square represents a chip. And these machines have a front end in the picture to the right. So the front end or front of the machine is used to receive cassettes full of these semiconductor devices or wafers, and then each of the wafers processed within the machine. A typical machine looks like this. What you see in front of the or outside of the wall are these yellow cassettes, and on the other side of the wall is a massive machine, and it can have it can have etching, deposition, or whatnot. It's basically semiconductor devices are built one layer at a time. So what Kensington, let's skip through this. So Kensington products are the front end automation of the semiconductor machines. You see a picture at the bottom left. That's a typical front end of the machine, and we make robotics equipment, different ways of moving the wafers around. There's always a front and back end of the machine in semiconductor industry. Front end is where the atmospheric handling happens. Everything is done within in atmosphere. And then there are a bunch of processes that are done in vacuum, and these vacuum can be, they have to evacuate all of the air inside the chamber. So there are some examples of our robots to move the wafers around, and we can move these wafers at very high speed, up to 150 wafers an hour, and each wafer can have tens of thousands of devices. So quite a bit of volume. And then with the wafers, we had to align the semiconductor, with the robots, we had to align these semiconductor disks or wafers. So we have a family of Prealigners, as they're called in the industry. So we can align the wafer and present the wafer in the right orientation in a manufacturing machine. And these are a number of different configurations of our front end. Again, it looks fairly simple. It also has a lot of automation built in. It has to be able to talk to the central factory automation group or the computer system. So it automatically it can identify what lot of wafers or what batch or what process of wafers are in any particular FOUP. There could be Apple chips in one FOUP, and right next to it there could be automotive components in the FOUP. So each of the wafer has to be processed differently. Again, once we marry our machine with a customer's machine, this is what it looks like. Our machine is in the front. We specialize in automation and reliability of automation. And the back end of the machine, in this case, is one of our customers' machine. They may have their specialty in deposition or etching or any other process that's helpful in manufacturing of semiconductor. The typical semiconductor wafer goes through upwards of 500 process steps. So the semiconductor fab is a busy place. And some of our other positioning products are XY stages. They can have precision of a fraction of a nanometer in some cases. So we build these stages to our customer specification, and majority of them are used for metrology or checking something on a wafer. Some of the examples of our work in process, this particular machine is for fiber optics alignment. And this is the outside of our building. We're located in Dublin. So welcome any questions at this point.
Rhonda, do we have any questions out there? I know we were going to wait till the end, but if there's something specific.
Yeah, there are no questions at this time.
All right, well, Raj, I'll have questions after the next presentation. So I want to say, Raj, thank you so much, because I know during Manufacturing Day, we've had students, you have opened your doors, and it's always been a highlight. So we're looking forward to be able to come back again when COVID is here.
We love hosting students here, so anytime.
Thank you so much. All right, we'll get back to you. Our next presenter is from Omron Robotics and Safety Technologies Incorporated, Director of Manufacturing, and that person is Venkat Raj Gopalan, and I welcome him to our presentation today. Raj.
Thank you. Can you hear me?
Yes.
All right. So let me share.
Venkat, yes, thank you. Go ahead, Venkat.
Yeah, before we get started, can you see my screen with the presentation mode?
Yes, I can. It's not in presentation mode. It's just in the slide normal view.
Sure. So before we get started, hold on, please. Let me
There we go.
Display setting and swap. Okay, can you see that? Yeah, I wanted to walk you through about who is Omron. So I don't know how many of you know, but everyone, when I ask, where do you work? Somebody asks me, and I say I work in Omron. What do they do? And I have to tell them that, hey, do you know about Omron blood pressure monitors? And then everybody says, yeah, we know blood pressure monitors. And then I say, okay, I work in the same company, but I'm in the robotics and safety technologies, part of the industrial automation business. So I wanted to walk you through about who Omron is, and then I would like to share with you what we do in these four walls, along with some of our robotic applications, and also share how we also partner outside the four walls with industries and also with students and also communities, okay? Let me, before that, I'll just make sure that I'm going to stop sharing for a minute, and then I'm going to start sharing again, because I want to make sure that you're hearing the voice too. Hold on.
At Omron, we go to work every day to answer one question: how can we contribute to more fulfilling lives and a better society? That is the focus of 36,000 dedicated employees worldwide. What does the future look like? Where will we generate value?
Can you hear me?
Yes.
Omron is the company of innovative automation. We are committed to improving lives and contributing to a better society. We are Omron. This is our story. A story that started 85 years ago and continues into the future.
So I wanted to talk about, what is our mission? So it's about improving lives and contributing to a better society. So when our founders started this company, they believed that businesses should create value for society through key practices, and one of them is through automation, right? It's not about just making money, but it's also about how do we drive social responsibilities and also enriching people's lives, all right? So today in our robotics and safety technology, this is a product portfolio that we have. As you see, this is just a set of all the robots that we have designed here and also manufacture in different locations. But some of them are like parallel robot, and then the SCARA articulated robots, and also collaborative robots, and also autonomous mobile robots. So when you can think about, collaborative robots, this is like something that can be easy to train on new tasks, and also capable of adapting to wide variety of applications like loading, like unloading, assembly, screwing operation, gluing, and also soldering, right? But the mobile robot is a self-navigating autonomous robot designed specifically to move material in challenging environment, right? And it's also very, very dynamic. So if you think about a facility, you don't really need any kind of a facility modification such as floor magnets or navigation beacons. So it basically is using the software that we have utilized and also being able to save in deployment cost. But these are all the products that we designed here and also manufacture in different locations. So this is where we are. Who is Omron Robotics and Safety Technology? So we are located in 4225 Hacienda Drive. So we moved from San Ramon and also from Fremont and merged the two safety and robotics companies into one. And we relocated the company in Pleasanton, and we opened the doors in Pleasanton in January of 2020, just before the COVID. And we have functions of new product introductions here. So basically we have a development engineers from mechanical, electrical system and software, product marketing, service, quality and operations, and also have ability for sustaining business. So we also manufacture some of our robots and also safety products out here, for which we also have like sales operation, production, planning, warehouse, and we also ship out the door from here. So in this particular slide, we talk about, innovative automation, right? So this is extremely unique for Omron Constant to bring innovation to production floor. As you can see on the screen here, this comprises of three concepts, right? Evolution and control, which is basically integrated solution, intelligence developed through information and communication, which is intelligent, and also interactive. How can humans and machines work together? So as a leader in industrial automation, Omron is able to offer manufacturers to be able to fulfill mass customization and also address issues related to raising labor costs and labor shortages. And as an automation company, what is the most important for us is to provide solution that is flexible and easy to configure. And we are at Omron was able to offer full portfolio of automation from ILO RS, input logic, output robots, and also safety technologies that we can do from factory automation from end to end. Wanted to touch base on this particular example. This is an example of an application of a parallel robot with AMP robotics in recycling operation, where the robot sorts material like plastics, paper, coffee cups, etc., at a rate of 80 items per minute. So sorting of waste is it's a very dull, dirty, dangerous. You think about humans trying to sort this, and it is extremely hazardous. And due to which, many recycling facilities do not only want to do this, but an operation like sorting can be achieved using automation through robots and also computer vision technologies. So this kind of application aligns with our core values. What is our business purpose? And that is also about how we really want to enrich lives. So as you can see in the screen, this robot is picking up different products with the use of vision cameras. And you can see, it's sorting papers to plastics. And this is something that we have about close to 100 robots that we have deployed in this particular facility. The next slide I want to talk about is an example of an applications where humans and machines work in hand, and that is an example of a collaborative robot where robot do not need to work alone. So if you think about a robot, you basically have a cage, and robots is going to function on its own. In this next application that I'm going to be sharing is going to be a robot and human interaction, and people can be free to what they can add value, and also the difficult and repetitive task can be done by the collaborative robot. So this is an example of an electric shaver manufacturing facility. In this particular application, this is one of this autonomous mobile robots which work together concurrently. So we have many different mobile robots from 60 kilograms to 15 kilograms of weight, but this is done through an enterprise manager which continuously monitor. Think about like a traffic controller, right? Telling the robots what to do, right? And assigning job functions. So we have this enterprise manager that can control 100 robots at a time. And this is an application where there are many different robots that are moving in concurrently. And also if you see this, what the example shows, this person, is putting something like a cabinet in the middle, and you see how the robots can self-navigate and travel around it and being able to find the best path to be able to get the job done. So I'm not going to go with the full slide, but I'm just going to give you an idea about what it does.
Coronavirus.
This is an example of, with COVID-19, when we all had to react quickly. So March of last year, 2020, when we had the COVID, and we had to come up with different solutions, and as different companies were trying to adapt to different technologies. So one of the things that benefited Omron is getting into the space of hospitality industry, where we are able to partner with system integrators like Topline to develop a UV mobile to disinfect the environment. It could be application used in schools, hospitals, or even in libraries, or even in mall or airports. But this is an example of a UV topper where, again, cleaning something where you want human beings to clean, can be extremely dangerous and risky. So how do we use automation to disinfect the work surfaces and also help in breaking the molecules of the viruses?
Shown the catastrophic results of poor hygiene and sanitation. Despite an effective vaccine program, the long-term effects of COVID will be felt way beyond the lifting of restrictions. Public places with high traffic and high-touch areas will need to guarantee the elimination of pathogens and bacteria to restore public confidence, enhance safety, and to protect brand reputation. The UVC Robot by Topline uses the proven method of UVC light sterilization technology to combat COVID and other viruses, such as SARS, MERS, and Ebola, in a thorough, faster, and less labor-intensive manner. UVC light works by using short wavelength ultraviolet light to distort the genetic material of harmful organisms, rendering them incapable of making copies of themselves. As opposed to manual cleaning that would require numerous personnel, when modelled on a 100,000 square foot supermarket, a single robot can complete the ceiling-to-floor sanitation process in 2 to 3 hours.
So, in addition to all the cool things that we do, in these 4 walls, we also look beyond these 4 walls. So we also partner with universities, schools, local agencies, and also partners. So last year alone, we offered like 6 internships to local schools, and also have tie-up with universities. For example, we have tie-up with University of California at Merced, and we also offer scholarships. And we also look forward to working with local communities and also schools in the Tri-Valley to support education and also talent development. We support STEM programs. We also encourage and support women in engineering and manufacturing. So it's a nice thing that we want to be able to have a diverse group and being able to attract talent locally. And that's one of our objectives, for being able to be part of the community. Thank you.
And thank you so much. I'm so happy you actually answered some of the questions that I had addressing the females. And we do a lot to try to promote women in STEM. And so thank you for that. And thank you for what you're doing for education, as well as informing the community. This day with all the speakers has been about really showcasing your companies and the back doors, the backyards of all of the community here in the 3 cities. And so we hope those of you out there listening today, or those who are going to see the recording, if you're looking for a career change, you're looking to maybe take that next step, and these might be some options for you. Or if you're a student who never really knew what manufacturing was, I hope that today has given you a glimpse of what advanced manufacturing is all about. And with that, I'm going to turn it over to Rhonda I think there's a couple questions that went back to Raj as well as Venkat. So Rhonda.
Yes, hi. So we do have a few questions. The first one, I think is it was received right after Raj's presentation. So the question is, are you experiencing labor shortage, and what are you currently hiring for?
You're on mute, Raj.
Sorry about that. Great question. We spend a good amount of time every day going over hiring processes and what we need to do to attract right talent. There's no doubt there's a labor shortage. We're looking to fill a number of positions, from simple positions such as shipping and receiving to technicians on the floor, both for mechanical engineering, for mechanical assembly, as well as electrical assembly, and customer service, engineering. We have and even sales. So we have a number of positions open. It has been a little bit challenging in our area. You would think that there should be a lot of workforce available. We are putting a lot of effort. We have sign-on bonuses, and we have employee referral program, and so I don't know if the question was anything in particular, but the short answer is yes. We're looking to hire a number of positions.
Great. And then I guess I could turn that over to Venkat. Do you want to address that as well for your company?
Yeah, sure. So first of all, to add to Raj, you always see, the traffic, on 580 and 680 corridor, and I always wonder, how come these people are all going to South Bay, when we have, opportunities here in the Tri-Valley, and we are, and we are looking for talent, right? And it kind of surprises. And I tell sometimes my HR and also recruiters to say, maybe you should just put in a banner on the 680 corridor, and maybe you can see people, wanting to see what positions open at Omron, right? But definitely, I do agree that we do see a lack of labor shortages and also the talent that we really want. For Omron, I think, we have a talent, job for, I think, every experience and talent. So we always constantly look for, different skill set. And especially with COVID, we launched about 10 new products last year, and which is super cool, right? And the COVID did not slow us down in launching our products into the market. So I would encourage that, please look into the Career website, and if I want, I can share it with Julie later on so that she can float it around. And there are many job openings that people might be interested.
Thank you so much. Rhonda, what other questions do we have?
Yeah, another question is about the global supply chain disruptions and how that impacted your businesses.
I'll take that first. A lot of our parts or the components that we use are sourced locally. We have a big supply chain locally. By local, I mean I don't mean Tri-Valley area alone, but Greater Bay Area. During COVID time, we developed some additional sources outside of the area, because in our industry, in semiconductor industry, things got really, really busy during COVID time. So that not only puts strain on us, but it puts strain on our supply chain as well. And I'm not talking just the computer chips. I'm talking kind of broader commodities, even the machine components or sheet metal components, everything seemed to have higher demand. So we try to develop sources in other parts of the country. We even partner up with a company that sources components for us overseas. So, but our intention always has been to keep it domestic. So it's been a little bit challenging, and some of our customers use the same sources. You know, we are in machinery building business, and so are our customers. You know, we build our machines, and our customers integrate our machines with their machines. So they have similar requirements. So it kind of put really tremendous pressure on our supply chain. We have built some inventories ahead of time, you know, to you know, compensate for it. And we also went out of the area to build our supply chain or supplement our supply chain. So those are kind of a couple of things we have done to overcome the current issue. And of course, it has impacted our cost. You know, we are in long-term contract with our customers, so it's not easy for us to raise prices to our customers. So we have been kind of absorbing the high cost in the short run, hoping for things to settle down a little bit and you know, see how it all pans out. But you know, we eventually had to go to our customers and pass the high cost on to them.
All right, well, thank you, Raj. And then Venkat, you want to take just a 30 seconds and maybe did it affect you at all or anything to add?
Yeah, definitely. I think we see a disruption as this whole ecosystem, you know, and I call it an ecosystem because not about supply chain alone, right? But I think, you know, what we are also seeing is because of the disruptions too, customers are now trying to shift to use of different technologies. I call it advanced technologies to create agile manufacturing and supply chain system, right? And that forces us also with this whole, yes, material shortage, I think Raj has already addressed, but I think we're also seeing new application requests from customers and adopting to new technologies. So it's all about innovation, right? How do we be creative in trying to solve the challenges that we are facing?
All right, great, thank you. And Rhonda, I think you had maybe one or two more questions. I know we could go a little bit over. I was just told by Lisa, but definitely don't want to keep people longer than probably 2:35. So Rhonda, what was the other question that you had?
The other question comes from someone who says they're a 52-year-old sheet metal worker that has spent most of their career installing HVAC systems. They wanted to know whether or not there are positions that a person with that type of experience, sheet metal fabrication, and or installation skills could, if there was a spot for them in an organization like one of yours.
Yeah, certainly. I will, if you can pass on my contact information, if the person can send us their resume, we'll certainly look at that and see where we can find a position for a person like that. That's great experience. That, you know, HVAC plus the sheet metal experience, that requires a lot of mechanical aptitude and problem solving, and those are two big attributes that we look for in people.
Great, thank you. Rhonda, was there another question?
Yeah, there is one more question. What are the biggest challenges for these manufacturers right now? Is it attracting or retaining frontline employees or regaining lost revenues due to clients being affected by the COVID pandemic, or maybe improving supply chain logistics disruptions? Or is there anything else that you find is your biggest challenge right now?
Maybe I can go on this. I think with one of the biggest challenges, of course, is to find the high quality workforce. You know, that's been an ongoing struggle. But at the same time, as we think about what has happened last year, how do we, as businesses, right? How do we really think about rethink risk management, and also think about business continuity plan, and also keeping workforce safety and innovation at the same time? And this is constantly evolving for us. So our focus is now shifting to immediate challenges to ensure business continuity and keeping employees safe, but also focusing on how can we think about a strong ecosystem by leveraging our automation capabilities, and also think about parallel production across various continents, because Omron has its presence in various continents and have a global customer network.
Thank you. And Raj, do you have anything to add, or?
Well, I think the labor shortages are the biggest worry right now. So I think we've talked enough about that. So it's not just finding people; it's also retaining people as well, because there are a lot of opportunities available at this point. Other thing, we buy components that are made to our specification through our supply chain, and what we hear in our supply chain are same issues. We hear that they are having their own labor issues, and we also find that even the raw material shortages are there, and they keep creeping up from time to time. So at this point, we just feel like we have to be really, really vigilant at business, because we can't take anything for granted. Of course, safety is paramount. We're constantly reviewing our safety protocols and implementing processes to do that. But at this point, you don't know what's gonna creep up. So you had to kind of be you have to be 100% alert at this point.
Well, thank you for that. Thank you both. Thank you so much for both of our.
Julie,
Yes,
we
Rhonda.
have one more question. I apologize for interrupting.
Oh, yes, no problem.
One more question in there. It's regarding whether you ever have any job fairs and then internships. Are they just for college students, or do your internships include high school opportunities as well?
We look at case by case basis, Rhonda. So it really depends on the candidate. So we like face-to-face interaction. So anybody looking for internship or even a position, I would highly encourage them to call us, email us. We'd like to kind of interact and see if we can find a room or make accommodation for internship or a full-time position.
Great. And Venkat, you mentioned it in your presentation.
Yeah, we do. In fact, some of our development team members went to Amador Valley High School and spent some time with the students. I think we also donated some robots there so that they can use it in the lab. So we definitely like to partner with schools and be able to, see and give opportunities to the local students, right? We also have partnership with universities. So right now, we always try to work with different universities. And if you see from my slide, right, it's not just one university we partner with. We have about 10 to 15 universities in Americas where we partner. But we definitely want to encourage students and we'll be happy to be part of a solution for the local chapter.
Thank you so much, Venkat. I want to thank you both, all of our speakers today. I know that the lab also has summer programs as well. I know Chris is off, but there are programs to engage there. I know for me personally, as someone who works with the 3 cities and the school districts, it's so nice that businesses open their doors. And, a lot of COVID has devastated so many people's lives, but in some ways it has also changed the lens. It's had people think in a different way, which is what we always talk about in STEM, to look at things from angles we never thought possible. And one of the things I was thinking about as all of you were speaking is we have started to do virtual field trips. Now, of course, we want students to be able to go to Manufacturing Day like they used to, or the community to come and see what's in their back door. But for those businesses that are out there that weren't featured today, let me just tell you, your cities, as well as the schools, we want to have you open your doors too, virtually. If you can't do it with people inside, we have teachers and classroom science classes and arts classes that would love for you to do a little piece and just take your phone and go around and show us your business and how kids can get excited and learn about your job. So I know that on the screen you can see now, there's my email address. So if you're interested in maybe being part of a future Manufacturing Day, or you want your business, you would love to engage with the city, or you'd love to engage with the school district, please reach out to us. This was recorded, as you know, and will be available on all the city's websites, as well as Tri-Valley ROP's website. Again, I want to thank all of our speakers, Chris, Raj, and Venkat, for being here today, and our city leaders, for Teresa and Rhonda and Lisa. Thank you all so much, and have a great day.
Yeah, thank you.
Thank you, Julie.
Bye.